Okay, 11-2 from Algebra 2, Arithmetic Sequences. A sequence is just an ordered list of numbers. An ordered list of numbers. Get that jotted down here. You might want to pause it because I'm going to switch screens here. I'll come back to this in a second, but I want to show you. Here is an ordered list of numbers. 3, 5, 7, 9. Obviously, it would continue 11 and 13 and 15 and so on. Okay? We'll talk about that in a second. That's a list of ordered numbers. Now, what I want you to think about is this. We talk about them 3, 5, 7, 9 as the first term, the second term, the third term, and the fourth term. Now, you're going to see notation. Notation which represents different things. Like n represents the name of the term. So n could be a 1 or a 2 or a 3 or a 4 or 17 or 57. All kinds of different things n could be. But the lowest it could be is 1, and it will always be an integer. So I guess you could say it would be a natural number. A sub n represents the value of the term. So a sub 1 in my previous example was a 3. A sub 2 was 5. The third term was 7. A sub 4, the fourth term, was 9. So in other words, these are like x's and y's. So kind of get into the habit of understanding that the name of the term is like the x, and the value of the term is like y. So it should be fairly comfortable to you. Now, along those lines, when you keep going through your list, there'll be a fifth term, and there'll be a sixth term, and a seventh term. Somewhere down the line, there'll be what we call the nth term. And that's just a place in the list somewhere. Well, what's after it? A subscript n plus 1. What's before it? A subscript n minus 1. So anytime you're going to start seeing these things a sub n and a sub n minus 1, they have a relationship to each other. You've got one term, and then you've got the previous term. So we'll be talking about the next term and the previous term. Okay, let's go back over here. The arithmetic sequence has what's called a constant difference between the terms. All you need to do is take any term. So the constant difference is any term minus the previous term. Any term minus the previous term. So if you take 5 minus 3 and 7 minus 5 and 9 minus 7, every single time you do it, you should get the same number. If you do not, then the sequence, even though it's an ordered list of numbers, we would not describe it as arithmetic. Now there are two different formulas you're going to be seeing. One of them is called recursive, and the other one is called explicit. Now, the recursive one is not the most useful thing in the whole wide world. There are patterns of sequences out there where you can only find a recursive pattern. If you can find an explicit pattern or explicit formula, you will always use that one. So I might ask you to write a recursive formula, but I'm not going to ask you to do anything with it. The explicit one is the one we will use all the time. Well, let's understand the recursive. The recursive has two parts to it. It tells me the starting value. So it says that the first term is equal to a number. So this is the starting value. And then it says this, a sub n equals a sub n minus 1 plus d. In other words, remember how we talked about that list of numbers? We had a sub n and then a sub n minus 1 behind it or previous to it. So this says that the next term in the list is found by taking the previous term and adding d, whatever that constant difference is. So for my example with the 3579, here's what it would look like. The first term was a 3. The next term is equal to the previous term plus 2. That was the constant difference between all those terms. So there it is. There's your recursive pattern. It's not difficult. There will be several formulas in this chapter, and yes, you will get a formula sheet for those. Now, the explicit one, I said, was a lot more useful. I said you were going to use it a lot more. Well, it should look real familiar to you. Remember how I said a sub n and a sub 1, they were all y values? Well, it should look real familiar to you because it looks, oops, sorry, that should be a plus. It looks an awful lot like the point slope form of a line. So for my example, the next term is equal to the first term plus the constant difference times n minus 1. Now, if you had to pick one of these that you were going to use to find, say, the 500th term, which one would you pick? Because in this one, I start with 3, and then I add 2 to find the second term. And then I add 2 to find the next term. And then I add 2. So I'm up to the 4th term now, right? I've got to get to 500. Right? And then I add 2, and then I add 2, and then I add 2, and then I add 2. What are we up to now? We're up to the 8th term? Whew! It's going to take a while. No, I do not want to know. Do not want to use this method to find the 500th term. What I do want to do is use the 500 inside this formula for n. 3 plus 2 times 500 minus 1. Can't believe I just said what I do want to do. Okay. I got there 3 plus 2 times 499. 1001. So the 500th term is 1001. A lot easier to find if I'm using the explicit formula. Example 1 asks you this question. Says, is the given sequence arithmetic? Oops, I need to get it down from there. See? If yes, what's the constant difference? Okay, so subtract those two. So 4 minus 2 and 8 minus 4. Oops, I get a 2 there. I get a 4 there. Uh-oh. That is not the same amount each time. So that's a big no. What about this one? 12 minus 6, 18 minus 12, 24 minus 18. Well, I think that's it. I think that's the winner, yes. And the constant difference between the terms is 6. Not too bad, huh? So in example 2, it's a fundraising situation. This particular organization has already raised $1,100 in donations, but they're telling everybody in their group that they must also raise $35 per person. So what's an explicit formula for that sequence? Well, consider this to be your constant difference, and consider this to be your first term of your sequence. So a sub n is equal to the first term plus the constant difference times n minus 1. There it is. All we had to do is plug in first term and the constant difference. How much money will be raised for 75 participants? Okay. So, in other words, what's the 75th term of this sequence? Well, you know what? We got to be careful here, folks. 75 participants is really the 76th term of the sequence. Right? Because the first term is 1100. That includes 0 participants. So we really need to change this to a 76. And we need to make this n a 76. So 1100 plus 35 times 75 makes a grand total of 3,725. The next thing we need to talk about is what's called the arithmetic mean, but you basically already know this. This is your basic average. You've already talked about this, done things with it, so it shouldn't be too bad. Example 3 says find, I'm talking about adding two numbers together and dividing by 2. So that's pretty easy, right? Find the missing term of the arithmetic sequence. We can use this idea of an average to find the missing term. So we have 110 plus 84 divided by 2, so 97. That's pretty straightforward, pretty easy. Your arithmetic mean is just your average. Okay, now, the notation looks different, but it's the same type of question. We know that a sub n is some term out there in a sequence. The one after it would be a sub n plus 1. The one before it would be a subscript n minus 1. They tell me that a sub n minus 1 is 7, and a sub n plus 1 is 1. And they're asking me, what is a sub n? Well, they're asking me for the missing term, just like the last question, except they didn't use all that weird notation. So it's found the same way, 7 plus 1 over 4. Well, why am I saying over 4? Probably because I know the answer is 4, right? 8 over 2 does give me 4. So that's the missing term. That's a sub n. Well, what if I had 5 numbers total and 3 of them in the middle were missing? Well, we could take the 2 and the 14 and we could average those together. Which one would that give me? Yes, that would give me the one in the middle. So 16 over 2 is 8. So how am I going to find this one? Yes, average these two together. Put it there. 2 plus 8 over 2. That's 5. Average these two together. 8 plus 14 over 2. What we got there? 22 over 2 is 11. Oh, look. It's smiling at me. Anyway, that's how you find the missing numbers, right? So find the one in the middle and then keep going. See you in class.